Video number 180, graphing some more interesting sine functions. Hopefully we learned in video 179 what happens when you have a 5 down here and what happens when you have a 3 up here from previous videos. But we need to get our basic sine function values on the graph. We need to take a look at what's happening at pi, what's happening at 2 pi, or if you want to consider this 180 degrees. Pi over 2 is obviously 90. 3 pi over 2 is 270. If you need to, make your reference unit circle to help you figure out what's happening. And of course, I think we can see here our range is 3 and -3 right off the bat. Right off the bat. 0, 0 is definitely what's happening here. The sine of 0 is definitely 0, right? Because you got a 0 height. Which means there would be a 0 height over here, which means sine of pi would also be 0 as well. However, we are not going to be plugging in those numbers, are we? We're going to have to multiply everything by 5. So this would actually be 5 pi over 2, 5 pi, 15 pi over 2, and 10 pi. Okay, so that's what we're looking at. At 360, we're back at 0 again. And what's happening at our 90s and our 270s? At 90, we are up here. 270, down here. So we'd end up with our sine function. Of course, you can go back and check out the basic sine function videos, 176, something like that, 177. And we're all set. Now, oh, by the way, I think it's worth noting and pointing out that this graph doesn't just start here. We also could take a look at what's happening over here at the negatives as well. If you were just to go ahead and, this would be negative 5/2 pi, negative 5 pi, negative 15 pi over 2, negative 10 pi, and of course you would end up with down here at -3. Curve back up at 0, up at +3, and then back at 0. So this graph would continue. Okay. Alright, next one. Y equals negative sine pi x. Hopefully we learned that when there's a pi in front of the x, by the way, we refer to this as a cycle in other videos. You could also call this a period. A cycle or a sine period. Either way, it's fine. Negative sine pi x, what does this mean? Well, it means we're going to divide all the pi's out of there. Instead of this being 2 pi, it's 2. Instead of this being pi, it's 1. Instead of being pi over 2, it's just 1 over 2 and 3 over 2. The pi's are gone. However, we're still at 0, 0, right? But instead of, instead of our first point, the quote-unquote what would have been 90. Well, if you notice here, what we're doing is we're taking a look at what happens at 90, 180, and, oh, not 360 yet, 270. Stop in between there. That's your 3 pi over 2 action. And, of course, our 360 action. So, this is considered our 90 point. That would have been our pi over 2. What's happening at 90 is you're going to end up over here at 1. But the 1's getting multiplied by a negative, so you're actually going to be at -1 to start off. So what happens is basically this graph gets kind of reversed, kind of inversed. Not necessarily inversed, but the range goes to negatives, opposites. So we'd end up with, we'd go down first instead of going up. Okay? Alrighty then, next one, y equals negative sine x over 4. This has a little combination of everything. We would revert to our unit circle, and of course, 1, -1. And where are you at here? We're at pi, 2 pi, pi over 2, and what would have been 3 pi over 2. However, what are we doing? If there's a 4 in the denominator, bam, we are multiplying everything. So this is going to be 8 pi. That's going to be 4 pi. This would be 4 pi over 2, which is what? 2 pi. This would have been, let's see, 4 times 3 over 2, which would definitely be, I think, 6. Yeah. Of course, you're going to have this pattern here where they're all going to be different by 2. So here you are. And because we got the negative, instead of going up first, it would be down to -1. And we would catch the +1 on the back side over this way. So, bam. All right. Here's an interesting one, I suppose. Y equals pi times sine pi x. I don't know. Not really all that interesting. What's the difference here, right? What's the difference? Well, this kind of makes things a little bit interesting. Instead of 2 pi, it's 2. Instead of pi, it's 1. Instead of pi over 2, it's half. Instead of 3 pi over 2, it's just boring 3 over 2. Now, the only thing I guess that's kind of cool here is the range value changes. We're going to go up and down pi. That's it. So it's not all that interesting. The graphs all pretty much kind of look the same, but obviously we want to graph them so they look the same. It would look different in your calculator, but here's the deal. The reason that they look the same is because we're changing the increments on our graph, even though, like in the last one, you know, here, let's take a look at one that's basically the same. Yeah, here you go. See that? We said this was 3 and -3 rather than pi and -pi. Okay, we said this was 5 pi over 2 rather than half. So the graphs look the same, but we're just changing the increments, which makes them, of course, different. So make sure if you are using a graphing calculator to adjust your windows, and of course, you're going to need to know the domain and range in order to do that. So you may want to make sure you have your x, min, and max from 0 to 2. That would be your domain, and then your range would be -pi to pi, and of course hard bracket, because this isn't a major thing, but yeah, that's what's being shown up on the screen. Questions or concerns, please send me an email, guys, and of course, good time.